Hello and welcome to my titration tutorial. Today I will be covering the procedure required for preparing a primary standard solution of sodium carbonate and will demonstrate how to use this solution in a titration to standardize a hydrochloric acid solution. Preparing a primary standard solution of sodium carbonate. It is important to note that the solid sodium carbonate used to prepare the primary standard solution must be anhydrous, in other words, containing no water. This is because hydrated sodium carbonate undergoes efflorescence, the loss of water upon exposure to air. This will occur as it is being weighed, making it difficult to determine its exact composition and in turn renders this experiment invalid. To prevent this from happening, the sodium carbonate must be dried in a drying oven at around 160 degrees for half an hour. It is then to be placed in a desiccator to cool, which blocks the sodium carbonate from absorbing moisture from the air. These steps confirm that the exact composition of the solid is sodium carbonate alone and that the experiment is valid thus far. A clean dry beaker is then to be tared on an electronic balance and approximately 2 grams of sodium carbonate is weighed out into it. This mass does not need to be exact, but must be known to be compensated for in the calculations. Once the solid itself has been prepared with its mass recorded, it must be dissolved completely to ensure the solution is of uniform composition, increasing accuracy. This is done by adding around 20 milliliters of distilled water to the beaker and stirring the mixture with a stirring rod, which must be kept in the beaker at all times to avoid any loss of sodium carbonate. This sodium carbonate solution is then poured via a small clean funnel into a volumetric flask, pre-cleaned with distilled water. To ensure all the solution has reached the volumetric flask, a wash bottle is used to rinse around the beaker and any seen solid into the funnel. It is then important to rinse the stirring rod into the funnel and the funnel into the volumetric flask with the wash bottle to prevent the loss of any sodium carbonate. If any solid is still present at this stage, stopper the flask and shake it until it is completely dissolved, as this is very difficult to do once the flask is full. This ensures the solution is homogeneous. At this point, the volumetric flask is ready to be filled with the distilled water until about 1 centimeter under the graduation mark, whereby the funnel is taken out. A dropper is used to fill the rest of the volumetric flask until the bottom of the meniscus lies on the graduation mark when read at eye level to avoid a parallax error. It is important to remove the funnel prior to filling the volumetric flask, as the process of removing it may cause water to drip and exceed the graduation mark. The flask is then to be stoppered and shaken well to ensure that the sodium carbonate solution is of uniform composition. The preparation of the primary standard solution of sodium carbonate is now complete. How to use the sodium carbonate solution to standardize a hydrochloric acid solution. The next step is to prepare the burette. It is important to ensure the burette is rinsed with distilled water to clean out any impurities which may affect validity. This is to be done 3 times by swirling the distilled water around the burette, ensuring it reaches all parts and then allowing it through the tap. The burette is then to be rinsed with the hydrochloric acid 3 times in the same manner to avoid dilution of the acid with the water. The burette is then to be clamped to the retort stand, as shown in this image, and filled with hydrochloric acid to the 0 mark via a small funnel. To be as accurate as possible, the burette can either be filled to above the 0 mark, in which the tap is opened until the meniscus lies on the 0 line when read at eye level. However, it can also be filled to a little below the 0 line and filled up using a dropper until again the meniscus lies on the 0 line when read at eye level. The burette is now prepared, so now it is time to prepare the pipette. Just like with preparing the burette, the pipette is first to be rinsed with distilled water 3 times before being rinsed with the sodium carbonate solution from the volumetric flask. This is done through the use of a pipette filler by pressing the A to squeeze it and the S to draw up the solution. Ensure it is swirled around and reaches all parts of the pipette up to the engraved mark to ensure the sodium carbonate solution is not diluted. Once rinsed, the pipette is filled with the sodium carbonate solution in the same way to the engraved line. As with the burette, it is crucial that the bottom of the meniscus lies on the engraved line when read at eye level to avoid a parallax error and maximize accuracy. This solution, the aliquot, is then transferred from the pipette into a clean conical flask. This must be done with the tip of the pipette placed against the glass wall of the conical flask to ensure that aliquot is fully transported to the flask with no clinging to the flask's neck or upper height. It is then released from the pipette into a clean conical flask through pressing down the E on the pipette filler. This conical flask now contains a known volume of the sodium carbonate solution, and the titration is now able to begin. To begin the titration, add 3 drops of methyl red indicator into the conical flask and swirl for uniform composition. It is important to ensure not too much indicator is added to the conical flask, as it is a weak acid and can therefore affect the pH and endpoint. Indicator is important as it helps mark the endpoint of the titration by changing color. In this case, methyl red was chosen as it changes color from yellow to pink over the pH range 4.4 to 6.0. This is the closest match to the equivalence point, the point where the hydrochloric acid has stoichiometrically neutralized the sodium carbonate. Place the conical flask under the burette, but on top of the white tile so that the apparatus is as shown by this picture. The white tile aids determining the color change of the endpoint and hence increases accuracy. The next step is to start titrating the hydrochloric acid in the burette against the sodium carbonate solution in the conical flask. This is done by opening the tap with one hand to slowly release the hydrochloric acid, while swirling the conical flask with the other hand to ensure the reagents are thoroughly mixed to determine the endpoint. This continues to the point where the solution in the conical flask changes color from yellow to pink, the endpoint. It is very important to read the volume of the burette at eye level from the bottom of the meniscus to avoid parallax error. This volume, the trite, is the amount of hydrochloric acid needed to neutralize the sodium carbonate solution, and therefore it is crucial to accurately record this volume for the calculations to be as accurate as possible. The purpose of this first titration is to locate the approximate endpoint. So in following titrations, when a couple of mils away from the endpoint, the tap can be nearly closed, only allowing the titrant to drop slowly. The first titration is therefore a rough titration, and its results are not taken into consideration in the calculations. Prepare another conical flask with the aliquot and indicator, and refill the burette to the 0 line in order to perform another titration. In these following titrations, it is important to be as precise as possible. When the tap is dropping, add 1 drop at a time. Swirl the conical flask and observe whether the color spreads and if the endpoint has been reached. To increase the accuracy in this process, a wash bottle can be used to transfer small drops that have not yet been completely formed from the tip of the burette into the conical flask. The wash bottle is also useful to rinse the sides of the conical flask if any liquid splashes while swirling. Once the endpoint has been reached, a very light and faint pink should result in a conical flask. Just as with the rough titration, record the volume on the burette, prepare another conical flask with the aliquot, and refill the burette to perform at least 4 trials to increase the reliability of the titration. Ensure to record the volumes of hydrochloric acid from the burette of all these trials that resulted in the endpoint to be used in the calculations to determine the concentration of the hydrochloric acid solution. That's all for today, and thank you for watching my titration tutorial.